we will get started. So the purpose for today's class is actually review. So what my plan for today is actually to go through just an overview of the topics for this so-called super quiz. I'll talk about the mechanics of the super quiz, and and then we'll talk about topics, and then basically I'm looking for, like I often do with reviews, I'm looking for questions from you, things that you'd like clarification on, examples I can do, that sort of stuff. So what I want to do is, first of all, let's get started with the first of all, the broad outlines. Okay, so the so-called super quiz is done. The mechanics of it are that you'll have 24 hours, and think of it as basically being a take-home exam. There's two pieces to it that you have to do, and they'll both be in Moodle. The first part actually looks just like a homework assignment. It's a Moodle homework. It's a Moodle assignment, and the contents of it look a lot like the homework assignments that you've had so far. The second piece to it is a VPL programming lab that has 3 problems in it, each one of which asks you to write a short function that does something. Okay, the difference between this in a lot of ways and the lab, and what Tyler does in the lab, is that these, for instance, the VPL, the 3 programming things, they're actually pretty short functions. They are exactly the sort of thing that I usually put on exams, which is where I will ask you to write a function that does this or does that. And the VPL things, there's 3, like I said, there's 3 of them in the VPL, and each one, there's 2 examples of how the function should run, and then there's a block of code at the bottom that actually just calls the functions so that they can be tested properly. I would ask you not to change the code at the bottom, because if you do, the tests won't run properly. And I have, if everybody turns it in, I have over 50 of them to grade, because if you get them right, VPL actually will test them and just tell me that you did great. So that's the mechanics of this, like what I'm calling so-called super quiz. My allergies are still kicking up. All right, so mechanically, that's where we're at. Is that will run Thursday morning to Friday morning. Basically, it'll be open for 24 hours. It replaces Thursday's class. It's not fair for me to give you basically an exam and then tell you, oh, and you have to do class in that same time period. However, Thursday morning at this time, I will be here on Moodle to answer questions. I will also have office hours Thursday afternoon if you have questions, and you can send me emails if you have questions. Okay, so you know what we're looking at for Thursday is, think of it as a take-home exam. I don't think you'll find, well, it's easy for me to say, right? It's easy for me to say, I don't think you'll find it too hard. But I don't think you'll find it too hard. I think you will find the Moodle assignment part relatively simple, and I think you will probably find some of you the VPL programming, the 3 programming pieces, to be a little harder. You'll have to be able to do functions and loops and things like that in there, and that's the part of it that's sort of comprehensive. Okay, so questions about that? I get the question, is the proposed grade function reliable? The answer to that is not really. I look at all of them generally, although I've had a few that have slipped by me where the proposed grade function throws out something that just doesn't make any sense. and to be fair, the reason the proposed grade function isn't that reliable is that I create one test case instead of a group of test cases. I'm still kind of a novice at using VPL. Do you have to complete it in one shot? No, actually, and there's two questions. Do you have to complete it in one shot, or can you come back at a later time? And is there a time limit? And the answer for both of those is no. It's really more like 2 homework assignments back to back with a 24-hour time limit on them. So yes, there's a time limit, but it's basically just that the assignment will open on Thursday morning and it will close on Friday morning. Okay, so that's really, it's not like one of these where it's timed and you have 2 hours to do it from whenever you start it. It's actually pretty flexible, and you know, I don't. What is then? Can you explain what you mean? Yeah, and so the one where the proposed grade was really bad, did I already look at yours? Because if I didn't, send me an email and I will. Okay, so the then was for homework. If then else if. Oh. So yeah, I got a bunch of questions. Some of them are coming in privately. So if you want to start on it in the morning and then work on it for the whole day, the answer is yes. Now, let me explain why I'm doing that. I don't know what your circumstances are right now. And certainly I can't do it at a specific time in our time zone, because we have students in our department that are 9.5 hours different. Some parts of India are 9.5 hours different from Eastern Daylight Time. There are some folks, I believe, in Japan or China who might be 11 or 12 hours off. Okay, so if then else elif. So Python doesn't actually have then. Let me that comes from my using other languages in the past, and I apologize for that. So in Moodle it says if then else elif. In Python you don't need the you don't need the then. The then was a keyword that is required in several programming languages that I first started programming in. Really in Python it's if, else, elif. If, elif, else are the only things that you have to do. So yeah, that was my bad under the secondary topics to put in then. I'm just used to, that's just what I'm used to. Okay, let's let me pull up. I have here, I'm going to do a screen share. It's interesting that it's not offering. Huh. All right, hold on a second. Why is it not offering to share? That is not. All right, hold on. The computer is behaving oddly. Oh, well, there you go. So we're going to need to wait a minute because Microsoft decided it wanted to update PowerPoint, and the PowerPoint that I had started, it just decided to close. And I had actually started a PowerPoint to talk about topics, and there it goes. It just went away on me. So let's pause. Let's all pause for a moment to reflect on Microsoft's ability to do updates at the worst possible moments. I've actually seen, I saw this when I was at IBM, I actually saw this happen to someone during a presentation. Their laptop decided that it had to shut down and restart to do a mandatory patch that the company had required. All right. It says it is shutting down. Let's see if I can open it back up again. It says updating Office. Please wait a moment. There we go. And it started back up. And let's see if, and I lost, and it caused me to lose. There we go. Nope, there it is. All right, we're back. That was awkward. Yes, I get it. You installed updates. That was really not nice of you. You are not a nice program. I do not like you anymore. And I still can't see it in screen share. All right, just a second. Something weird is happening here on my computer. I am trying to share a screen to Zoom, and it is not showing up. I'm closing everything else. Let's try this then. All right. Just give me a second here while I try to understand what just went haywire. Now then. All right, hold on a second. I am going to, I don't know that I can do that. I can't get it to share anything. So I will just share the screen. So you should now see my screen. And I was trying to share a window and it just did not want to let me do that. Really? Other stuff wants to update. All right, here we go. So this is a quick summary of the review topics. Okay, these are the things that I have selected. And if you look at this, this is basically the stuff that is since the first midterm exam. The topics here, strings, lists, tuples, sets, dictionaries, mutable and immutable, ordered and unordered, and common sequence operations, right? That's the kind of high level sort of thing. These are all collection classes. Now, this, as I put in Moodle, the secondary topics are the things that you kind of have to know in order to be able to do some of the things like the virtual programming lab. Okay, you'll need to know some things about doing functions. You might need to know iteration, for and while loop, that kind of stuff. Okay, so let's start with maybe, you know, if we want to talk about, let's say, strings, right? What are the things that we did with strings? Right? Well, we did slicing, we did nested strings, right? That's this. We did the concatenation and repeat. That's plus and star, right? Yep, they are immutable. Exactly. We had a bunch of string operations that we could do. And examples of those are things like index. Oh, let me pull up my notes. Where did I put my notes? That's weird too. Stuff is just like disappearing on me these days. Hold on a second. There it is. There is the notebook with those notes in it. Okay, I just want to get the kind of the list, kind of a full list of string operations that we talked about. And the best place for me to go is to my notes here. Okay, stuff we did with strings, fun with strings. Here we go. Upper, lower, length operator, find, split, join, strip, L strip, R strip, R find, is digit, is alpha, is lower, is etc. Right? These are all things that you can do to strings. These are all string operations. We also had in, which tells you if a substring is in something, right? And we had ord, which tells you for a character what its ordinal value is. These are all string stuff. That's correct. So good point there. Also, they are ordered. They are immutable and they are ordered, okay? Now, let's look at lists, right? Lists are mutable. They are ordered, right? They have the length operator. They have the in operator, just like our strings did. Skipping forward here. I can do these off the top of my head, but I'm afraid I'll forget things. We have append versus extend, for example, right? Two different things that you can do with the list. We have sort, extending here, sort. We have del, which is an operator that deletes an item out of one. We have pop. We have insert, right? We can create a list, right? T equals a list. We can also say T equals list and put a string in there, in which case it does something different, right? That leads us to, we also have split and join, which are string operations with lists, right? They're things that move you back and forth between a list and a string. We have assignment versus copy, right? T equals S versus T equals S dot copy. Let's see, pop and append. We have slicing as well, which behaves like string slicing. Okay, so that's a rough, pretty much a summary of what lists are. And lists, again, I've said this before, lists are kind of the king in terms of Python collection classes, right? As collection classes go, lists are the ones that are the most powerful, and they are the ones that we use the most and that you will find to be the most useful. All right. So then we get to tuples. Tuples look like a list, but are immutable. So things like in and find, a lot of these things you can do, and slicing, but no append, extend, sort, del, right? You don't have any of those. Just like a list, immutable, ordered, faster. Okay. Then we got to sets. So sets are mutable. They are unordered. Order is arbitrary. They are unique elements. No duplicates. Right? That's kind of the very top level overview of how sets work. The thing that sets have got, and again, I'm looking for my page that's got all those. Okay, so the thing that you can do with sets that's kind of cool is that sets do set operations like a Venn diagram, and or difference, union. I'm sorry, this and is actually, I do that sometimes. Intersection, union, difference, subset, etc. Those are all things that you can do with them. Okay, you can add. The methods include add, remove, pop, discard, right? And you can do in and length. Actually, I think you can do length. I haven't tried doing length on a set, so let's try this. Let's say S equals A, B, C, D, and we'll say T equals set from S. Okay, there's T, length of T. Yeah, length works. I've never had cause to try to do length on a set. That's why I wanted to check that before I said that. So you've got in and length as well. Now, dictionary, key value pairs. Keys are unique, values are not. This is mutable and unordered. Keys look a lot like a set, behave similarly, right? Well, what are the things we can do with the dictionary? Well, we can add items. We can do that just by saying D of key equals value. That's all it takes to do that, right? We can do in, which tests keys, right? What can be a key, right? So to be a key, it must be immutable. So things that can be keys are tuples, strings, int, float, Boolean sort of things. Lists cannot be a key. Sets cannot be a key. They can, what can be a value? Anything, including lists, sets, other mutable types, including dictionaries. You can have a dictionary that contains dictionaries, right? So, other things about dictionaries, right? One is we can get the keys, d.keys, unique, arbitrary order, d.values, again, arbitrary order, order, but might have duplicates. Sorted d.keys, right, or sorted d.values will tell us will give them to us in sorted order. You can actually do this. You can say sorted has a keyword where you can tell it you want them sorted in reverse order. Okay. Now, d.pop, right, gives you a value. d.pop gives you value, the value for key K. d.kv gives you the value or default V. In this case, or you get an error. Right? If the key is not present, you try to do a pop, it gives you an error. It gives you actually, it's a key error. It tells you it's not there. Let's see. Let's talk about, so I'm going to go, and in my notes, it's going backward to something we call common sequence operations. And what I want to do is I want to try to lay this out for you. So let's do this, and we will say, I want 4 columns, maybe 9 rows. All right, so string, tuple, list. Right? Here I can also say tuple or list. I hate the fact that it likes to alphabetize everything. Right? These are creation. Now, create empty. So that's creating empty. Creation, I can do this. I can say A, or I can say 5 comma, I can say 5. Right? These are ways of creating these. Length, whoops, darn it. Just want you to see that these are actually all, they're all very similar. Okay. Slicing. Start, stop, increment. Start, stop, increment. Start, stop, increment. For slicing. Numbering, 0 to length minus 1. 0 to minus 1, 0 to length minus 1, but we also have reverse numbering, negative length, negative length, negative 1, negative length, negative 1, negative length to -1. Concatenate. Repeat. Functions. Min, max, length. Min, max, length. Min, max. Right? These all behave the same for all of these types. Let's see, identity, in and is, in and is, in and is, right? These all, again, what I'm trying to show you is that these are actually kind of universals. There's a lot of stuff here that behaves exactly the same. So methods, count, index, count, index, count, index, these behave exactly the same as well. Python's kind of nice to you this way. Then we've got other ones here, right? More methods, upper, lower, find, rfind, index, rindex, place. There's not really anything equivalent there, but over here we have append, insert, extend, del, remove, reverse, top, sort. All right, so let me see if I can make this fit by playing some games with, oh, that's not what I wanted. I wanted to come in here. We'll start here and we will do this. And I will try to, there we go. So there's actually a quick summary, if you will, right, of what we call these common sequence operations. These are things that are universal between these three types. And the thing here is that these three are all ordered types. And because they're ordered, all of this stuff up here, it keeps wanting to grab that. All of this stuff up here is pretty much the same, right? So let's go over to idle and try a couple things. So one of the things I wanted to do, right, is let's start with that string. So I have this string s. So I can say s.split, right? And you notice there I got a list with just the items in it. Now, let's say that I have another string that says t equals, oh, here's the other one. The quick brown fox jumped over the lazy red. It's actually a red dog, red fox. Red fox jumped over the lazy brown dog. I remember my typing class correctly. The reason we did that is it has all the letters of the alphabet in it. All right, but if I say t.split, I get a list, right? So I could say that x equals t.split. I now have this. I could then say that y equals x.join. Let's see, what do I want to do with that for join? Splat. No, sorry, it's splat.join. Y equals splat.join t. And then what I did is I rejoined them, because split and join are string operations, right? Split and join are string operators. Easy for me to spell. Okay, We can do similar things though with tuples. So let's say I say T equals A, B, C, D, E. Okay. Now I can say, let's say, oh, I'll do this. Join T, right? It turns out that I can put almost any string in here. Supercalifragilistic. I'm not going much further than that. Dot join T, right? And it took this string and it joined all of the elements of T, because T is an iterable, as we like to call them, an ordered item. It's kind of the relationship between strings and lists, if you will. Strings and tuples, strings and lists. Okay. Now, how about some slicing stuff? All right, so there's a string. So let's say I say I want to take every third element of that string, or I take every fourth element of that string, right? Let's say I decide I am going to take from -1, and I'm going to go by -2. Okay, I just pulled items out, right? Remember, S of -1 is the far left element or far right element, and S of -2 is the next one. So if I say I'm going to start at the right edge and I'm going to go by negative increments, I'm going from one end back towards the start. I'm going from the end back toward the start. I could say I want to go from the 10th to the 15th element, right? I could say I want to go from the 10th to the 15th element by 2. Now, this will behave exactly the same as our set operation. So let's go up here and I'm going to do this, and I'm going to say I've got this T, and I'm going to do this so that split will work better for me. All right, and then I'm going to say that X equals T dot split. Now I have a set, or I'm sorry, I have a list X. So let's go up here, and you see here I did this one. Let's do that with X. As you notice, I got exactly the same elements here when I did the string as when I had a list with each individual letter in it. And all of these should behave exactly the same for me. If I do the -1 by -3, right? I got exactly the same elements out of the list that I got out of the string when I did the similar operation. If I try, let's go up and we'll do this one. If I do X, right, it's going to give me exactly the same thing. Ditto with tuples. Tuples will do exactly the same thing. If I say, so I create a tuple, if I were to create a tuple that had that same thing in it, the slicing would work exactly the same. So if I say length of X, if I say length of S, if I say A in X, if I say A in S, right? If I say X times 2, if I say S times 2, right? If I say S plus S of 10 colon 15 times 3, see what happened here? I took that slice that I had up here and I added 3 copies of it to it. If I take that same one and I do it with the list, I get the same thing. Here are 3 copies of that particular slice have been added onto the end of the list, right? What's the min of S? What's the min of X? What's the max of S? What's the max of X, right? That's working by using the ORD operator, right? Because ORD A, ORD Z, right? Those have values. Let's say s.count. Oh, actually, let's do this one. I'm going to take this and I'm going to put this into another list. So there's my list Y. Y.count K. There's 4 of them in there, right? Y.index K will tell me where the first one is. S.index K will tell me where the first one is. And if I were to take this one here and create a new string Z, right? This is a string now. If I say Z.count K, right? Z.index K. See the symmetry with this? How the string and the list here are behaving exactly the same, right? One is mutable and the other is immutable. But with respect to these things that we call these common sequence operations, the two of them basically work the same. Now, so I have this string Z. Let's try this. Z dot find K, okay? Z dot R find K. Z dot find gave me this one. Z dot R find gave me that one. What if I say Z dot index K, Z dot R index K, right? Z dot find 1, Z dot index 1, okay? The difference between find and index is how it behaves if it cannot find something in the string. You with me so far? Okay, let's see. Let's do a few more of these list things. So we have this list Y. I can say Y dot pop, right? And I can give it an index. So if I say Y dot pop index 2, it's going to return C, and Y no longer has that in it. So let's try to put it back. Let's do Y dot insert. It says insert the object before this index, 0, 1, 2. So I want to go to 2, and I want to put C back there. And it's back where it started, right? I took this element, I removed it with pop, and then I put it back using insert. You can't do that with any of the immutable types, but you can do that with a list. I can say Y dot sort, right? And now you notice all of these have been put in one place. That this is all sorted now properly. Then I can say Y dot reverse, and it runs the other direction. And Y dot remove. Okay, so remove the first occurrence of the value. So we'll remove the Z. It's gone. Y dot remove Y. That's gone. Right? Now I can say Y dot append, and I will put the Y on the end of the list, and Y dot append Z. If I look at it now, I've stuck these here. I can go back now and let's say Y dot sort, and then Y dot reverse, and Y looks back the way it did up here before I started messing with stuff, right? Some pretty cool, powerful stuff we can do with these. Now, let's talk about something else here, which is, let's talk a little bit about slicing. Okay. So we've got this start, stop, increment. But what I want to talk about is nested objects, right? So use the slices from left to right. Let me give you an example over here. So now let's start again. Let's say that I'm going to say T is a list. And then here I've got a list. And here I've got a list. Okay, so there's T. All right, so let's see, what is T of 0? Let's just go through these one at a time. T of 1, T of 2, T of 3, T of 4, T of 5, right? T of 5, 0, T of 5, 1, T of 5, 2, T of 5, 3, T of 5, 3, 0, T of 5, 3, 1, T of 5, 3, 2, T of 5, 3, 3, T of 5, 3, 4. So we just took this list here, right, and we teased every element out of it using slicing. Notice how that worked, okay? These are done left to right. So this was T of 5. T of 5 is a list, right? So what's the 0th element of that list, right? T of 5 is a list, so the 0th element of that is the 5. Element number 1 is the 6. Element number 2 is the 7. Well, element number 3, T of 5, element number 3 is a list. So the 0th element of this list is 8. All right, let's talk about let's talk about sets a little bit. Okay. So let's do a set here, and I am going to say, so let's create a set. S equals red, green, blue, purple, orange, yellow, magenta. All right, so there I have a set of colors. Now I'm going to say primary. Well, let's say what's the length of S, right? Is red in S? Yes. Okay, so RGB. So let's say primary equals red, green, blue. Or let's call this RGB. So there's my RGB. Let's say RGB. Let me find the subset operator here. So I want to say RGB dot is subset of S. That's true. Why? Well, because RGB has these 3 in it, and S has red, green, and blue in it. Notice the ordering here. I started out, I said red, green, blue, purple, orange, yellow, magenta. When I printed it out, I got magenta, yellow, orange, red, green, purple, blue, right? The ordering is arbitrary for these. It is an unordered type. Now I can say s.add. Let's add a color. Roy G. Biv. I didn't have violet. Right? So now S has violet in it. Well, that's the same thing as purple. So let's do S dot discard purple. Okay, so I've violet for purple in that set. What is S dot union RGB? Well, it turns out that's the same thing because it's in there, but what is S dot intersection? Intersection RGB, right? That will tell me the things that are in both of them. Now I can just arbitrarily do S dot pop, and it removed magenta, it's no longer in there. S dot pop, it removed yellow. Now yellow is no longer in the set. Now let's try this though. Let's say I want to do an S dot add, and I say I'm going to add to this yellow and magenta, and I'm going to add them as a list. Can't do that because lists are not hashable. However, if I do it as a tuple, I can add them, right? Because the only things that can go into a set are things that are hashable. And in practice, the things that are hashable are exactly the things that we call immutable. Okay? Are you with me so far? So far, I think I haven't lost too many people yet. All right, let's talk about dictionaries now. So let's create a dictionary. So D is a dictionary, it's empty. I'm going to say D of red equals primary. D of green equals primary. D of purple equals secondary. So if I look at D, I now have these pairs, key value pairs. Now, if I say, let's say, well, let's just ask it, right? D of red, it'll tell us that that's a primary color. That's what these are good for. So let's do D dot values, right? We get primary, secondary, primary, secondary. I can do list D dot values, right? And it'll convert it to a list. The D dot values looks like a list. It isn't really, okay? D dot keys, sorted D dot keys. Now they're in alphabetical order, and you notice sorted actually did convert it to a proper list for me, because it's the same thing. If I did this D dot keys, it would now be a proper list. Okay, so I can say other stuff here. There are a bunch of other things I can do with the dictionaries. I can say D dot get red. Oops, I need D, and it will get that for me. It didn't remove it. D dot get just gives it to me, but I can say D dot get yellow, and I'm going to say I want a default of secondary, right? Notice, because D dot get yellow, not there, doesn't give me anything, right? I can say D dot pop yellow, and that will throw a key error because the key is not present. That's a difference. In some ways, get and pop will remove it, but I can also say D dot pop yellow and give it a default, and it will say it's secondary. Now, if I say D dot pop red, okay, primary, and it removed it from the dictionary. So I can put it back in, right, pretty easily. I can say D of red equals primary. and now it's back in there. Okay, d.items. That returns for me this thing, which are the sets of them. I can say for I in, I can say kv in d.items, print e plus k plus equals plus v. What we did there is we iterated over tuples because the items returns tuples. Now, what can be a key in a dictionary? Well, let's say I want to say it's red, green. It was in a tuple equal set of primary. Right? So I've got that in there. But let's say I decide to do it this way: purple, orange equals set of secondary. And I can't do that. It's an unhashable type. That is literally the same error we got when we tried to put the list into a set. The keys of a dictionary behave just like a set. Right? But I can say d of 1 equals a number. Right? And I can say d of 3.1415 equals equals pi, right? And I've just added those to it. Now I can say del d of 1 and clean that out. Del d of 3.1415, right? And I've removed them from that dictionary. All right, that's kind of a whirlwind sort of overview of all of the collection classes that we've discussed. And this is the stuff that the super quiz on Thursday is going to be concentrating on, is these kind of things. We've got a few minutes left. Are there any questions? And if there aren't any questions, I will go ahead and I'll sign off. You can always feel free to send me emails. You know where to find me. I have office hours this afternoon after my my class that's after this. You know, I'll say going once, going twice. How should you study? It's hard to tell people how to study. And I want you to understand, right? This is different. This is more like a homework assignment, right? This is a lot less like a test. So my suggestion would be actually the stuff I went through today, make sure you kind of understand it. And I think that the main thing is, I always tell people with exams, is to try to relax, try to be well rested. This is a little different than an exam though. So I would hope that you find this, that you're looking at this and that this is less stressful than an exam. Certainly because of the time period you're given, you should view it as less stressful. How to study: review your notes, review the homeworks, you know, review particularly the VPL stuff that you've done, because there's going to be, you know, some of it is going to be that, and that's going to be an important part of it. And remember, Thursday I will be available to answer questions. And yes, Jalen, I will be posting this PowerPoint, the video, and the transcript from, what do you call it here? The oh look, Super Quiz Solutions. Maybe I shouldn't open that, huh? That would be bad, wouldn't it? No, I will be posting the idle transcript as well. So all that stuff will be up. It'll probably be up really shortly, and you'll be able to take a look at it. Okay. All right. So with that, what I want to say to you is please be well, and when you have an opportunity and you can, as much as you can, de-stress, right? And try to find a way to relax as much as you can, because I know things are pretty crazy. Depending on where you are, they may be crazier than they are other places. So just take care of yourselves, and that's really important. And if you are really worried about stuff or you're struggling with anything, reach out to somebody, reach out to me, to your advisor. You know, we can try to put you in touch with like the counseling center or anything if you're struggling. Okay. So with that, like I said, Thursday I will be online on Zoom to answer questions during class, and then I have office hours, and I'll be available by email as well. So take care and be well.